Hello, students. I am going through your review today just to kind of get you ready for this test. This is going to be a long video, so feel free to fast forward or rewind or go to wherever you need to get to where you're supposed to be in here. So our first question says to write the following functions in standard form. And standard form, remember, counts down from the highest exponent of the variable. So this one is going to be 5s to the fourth minus 2s plus 1. And this degree of this one is 4. Here's our degree. And this is a trinomial, a cubic trinomial. Or no, excuse me, quartic trinomial. Because the quartic is a fourth degree polynomial. Our next one is going to be 2x cubed minus 4x plus 9. This is also a trinomial. Trinomial means that there's 3 parts. It is a cubic trinomial of the 3rd degree. Okay, so number 2 asks us to sketch the graph using the clues listed and identify the turning points and x-intercepts. Our x-intercepts are given by our positive and negative intervals. So we're going to have one at -5, one at -1, and one at 3. And then it's negative from negative infinity to -5, and it's positive from 3 to infinity. So we know that that's what our end behavior looks like. So the next is to put in our turning point. So we have one at -3.5. So approximately here, but we're going to put it up here somewhere. And it doesn't really matter where the y value of that turning point is, so long as the x value is at 3.5. So we can connect those. And then our other turning point is at 1.25. So 1.25, about there. And we're going to go through that point. So these are our turning points. And then our zeros are, of course, those points that are given by the negative and positive intervals. 3 says in the following graphs, the leading coefficient is the leading coefficient positive or negative. So one of the ways that you can tell if the leading coefficient is positive or negative is to look at only the right hand in behavior. So if it's going up, it's positive, and if it's going down, it's negative. So in this case, we're going down, so this one is negative. In this case, we're going up, so this one's positive. And then the second clue to tell if it's even or odd, it's even if they're the same, if left and right hand in behaviors are the same. And let me be a little more specific with that so that if you're looking at this document later, in behavior same, and it's odd if the end behavior is different. So here our end behaviors are different, so this is odd, and here they are the same, so this is even. Okay, for number 4, we're going to add or subtract the following. So this one is adding. So adding is pretty easy. So we're going to add our like terms. We've got a 4x cubed and a 2x cubed, so 6x cubed. X squared and 2x squared is 3x squared. A 2x. And then a -8 and a +9 gives us +1. This next one gets a little bit trickier. I'm going to start, because it's subtraction, we're going to change this to addition and then change all of our signs for everything inside. So now we have 2y cubed and y cubed is going to be, or -2y cubed is going to be -y cubed. 6x squared and 7x squared is 13x squared y squared. -4xy and 2xy is negative 2xy, and negative 8 and negative 8 is negative 16. And then our last one, we have subtraction again, so we're going to add and change all of our signs. We have negative a cubed b plus 6a squared b squared plus 6ab, and then positive 6 and negative 4 is plus. All right, next is multiplying. This first one in number 5 is easy because you've just got a monomial out here. So we're going to distribute that monomial out. So we get negative 10c cubed d plus 10c squared d squared plus 2cd cubed. Easy enough. Now for this one, we have to do a little bit more work. So we're going to have 5b squared minus 4b plus 2 and negative 2b and 4. Do our box multiplication here. So we get negative 10b cubed, 8b squared, negative 4b, and 20b squared, negative 16b, and 8. And so that gives us negative 10b cubed plus 28b squared minus 20b plus 8 as our final answer. Okay, now we are factoring. This x to the 4th, remember that x squared is x to the 4th. And 256 is 16 squared. So this is the difference of squares. So we have x squared minus 16 and x squared plus 16. But we are not done because this is also a difference of squares. So this breaks down into x minus 4 and x plus 4. This part right here. And then our x squared plus 16. And so that gives this as our final answer. This problem we need to change to x cubed minus 27. So that means our a is x and our b is 3. So we have x minus 3, x squared plus 3x plus 9. And then our last one here, we're going to have a is 3, b is 2x. So we have 3 plus 2x. 3 squared is 9 minus 6x plus 4x squared. Okay, for number 7, it asks us to write this as the product of two factors. In order to do that, we need to find our linear factor first. And we do that by finding the 0. So, that means we're going to Desmos it up here. And we've got x cubed. Hope you guys are enjoying hearing my kids in the background. X cubed minus x squared minus 2x plus 8. So we have a 0 there at negative 2. So now we know that one of our factors is x plus 2. To find the other factor, we do division. So I'm going to do synthetic division. So 1, negative 2, negative 3, 6, 4, negative 8. And of course, if it's a 0, we should have a remainder of 0. And then we have x squared and x. So our factors are x plus 2 and x squared minus 3x plus 4. So if we're going to write it as the product of factors, we just write it like that. Okay, so now dividing these polynomials, we got to remember that we're going to put negative 2 in our box. 1, 7, 14, 3. And so we have -5 as our remainder. So we're going to write this as n squared plus 5n plus 4 plus -5 over n plus 2. Now, for this one, notice that this is not in standard form and neither is this. So this is going to be k plus 3. So we're going to put 3 in our box. And then these are going to be k cubed minus 4k squared minus 30k minus 18. So we're going to have 1, -4, -30, -18. Making sure I did that right. 1, -4, -30, -18. Bring down the 1. 1 times 3 is 3. -1 times 3 is -3. Okay. -3. 3 times 3 is negative. Oh, guys, that should have been a -3. When you get really weird numbers, double check that you did everything right. So yeah, we should have been dividing by -3. 1 times -3 is -3. -7 times -3 is positive 21, which makes this 9. 9 times -3 is -27. Our remainder is still stupid large, but at least I'm a little more confident that I did that correctly. So we get 45 negative. So we're going to have k squared minus 7k plus 9 minus 45 over 3 plus k, or k plus 3, however you want to do that. Okay, our last one here, I'm going to put 8 in the box. We have 1, 0, and 74. 1 times 8 is 8. 8 times 8 is 64. That's negative, so -10. So we're going to have x plus 8 plus -10 over x minus 8. Now notice, for this one I did minus, for this one I did plus negative, and for this one I did plus negative. It doesn't really matter how you do it as long as you have either of those. Okay, number 9 says find the zeros and describe the behavior at each zero. So again, we're going to go back to Desmos for this. And I'm going to graph. So we get x cubed plus 5x squared plus 7x plus 3. And we have a 0 at -1 and a 0 at -3. So at our first 0 is -1, and at -1 it bounces. So we're just going to write that it bounces, or it's a double 0. And at -3 it passes through. And that's as difficult as it gets. So now let's do the next one. This is a 5th power polynomial. So we get x to the 5th plus 2x to the 4th plus 8x cubed plus 16x squared minus 9x minus 18. And we have 1, 2, 3 zeros, 3 real zeros on this one. And guess what? It passes through all 3 of them. So we have -2, -1, and 1. And it passes through. Or you could say it crosses. Either one of those will be acceptable to me. Then our last one, I'm just going to start over. So we get 2x to the 3rd plus x squared minus 2x minus 1. And we have 3 zeros here as well. So we have a 0 at -1, at -1/2, and at 1. And it again passes through all of those. All right, so now for 10, we're going to sketch these given polynomials in standard form. And so to do that, I'm going to put my axis on here. And we have a 0 at -2. We have a 0 at positive 1/2. And a 0 at -3. So -3, -2, and positive 1/2. And this is an even, and it's positive. So remember, if I told you about that right-handed behavior, if it's going up, it's positive. And this is even, so they're the same direction. And so at -3, we go through. At -2, we bounce because this is an even power. And then we're going to connect back to our 1/2, and it should go through because that's an odd power. Okay, for our other one, let's put our axes up here. We have a 0 at 5, a 0 at 0, and a 0 at -1. So there's my -1, there's my 0, and there's my 5. This is odd, and it's positive. So positive means that over here at the end, we're going up, and it's odd, so it means on this end, we're going the opposite direction. And on this one, we don't have any double roots. So that means that we're just going to pass through all of them. And there's your sketch. So now for 11, we're listing all of our possible rational solutions. So those of you in my general algebra 2 class, you can stop watching now. We're done. Those of you in advanced, we keep going. So remember that this is our P, and over here at 3 is our Q. So first we are going to list our factors of P. So P is 8. So our factors are 1, 2, 4, and 8. And we've got the positive and negative of each one of those. For Q, we have 3. And we're going to have 1 and 3. So that means that our P's over Q's, for all of our possible zeros, are going to match all of those up. So we're going to plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3, plus or minus 8, plus or minus 8/3. And there we have it. We're done. For 12, we're going to find all the actual zeros. So when it says all the zeros, this is the actual zeros. So we're going to have x cubed plus x squared plus 9x plus 9, because we have to move that 7 over. And we're going to start by graphing this to get our real zeros. And hopefully at least one of them is rational. So we get x cubed plus x squared plus 9x plus 9. And, oh, whoops, I put equal sign. We don't want that. We want plus 9. So then our 0 is there at -1. And if you look at the whole graph, accidentally made it go away, sorry. I wanted to expand it. If you look at the whole graph for this, it's almost linear. It just has that slight curve to it. But our big news is that our actual zero, our real zero, is at -1. So then we take our real zero, which we know is -1, and we are going to do our synthetic division. So 1 times -1 is -1, 0 times -1 is 0, 9 times -1 is -9. So now we have x squared plus 9 as our quadratic. Now, you can do the quadratic formula with this, and if you did that, your a would be 1, your b would be 0, and your c would be 9. Or you can just move that 9 over and then take the square root. So we get x equals plus or minus 3i. So then all your zeros are -1, 3i, and -3i as your final answer. Okay, for question 13, it says, are the following functions odd, even, or neither? So for odd, all of the powers of x have to be odd. For even, all of the powers of x even have to be even. And if those two conditions aren't met, then it is neither. So if we look at number 1, we have an odd in the 5, but an even in the 4. And so that makes this one neither. For number 2, we have an even 6, an even 2, and then we know that this is x to the 0, which is also even. So this is an even function. And then here we have an odd, and then that invisible one there is also odd, which makes this function an odd function. Okay, last question. We made it. So how does this graph differ from the parent function? Well, let's start with the easy stuff that you guys know right off the bat. And that is that 4, that subtracting 4, on the inside of the parentheses moves this right 4. And that negative 4 outside, which I tried to change my color on here, says that we're going to go down 4. And then you should remember that any number out front is a stretch. And then, of course, if there were a negative, we'd have a reflection. But there is our transformation. So I hope this helps, and I will see you next class.